Converge or diverge, we have the series when n goes from 1 to infinity, n factorial over n to the nth power. And we see that because we have the factorial and also the n in the exponent, this right here is a great example to use the ratio test, right? So let's write it down. We will be utilizing the ratio test. And as we know, to do the ratio test, we have to take the limit as n goes to infinity. So let's write this down first. And we'll be working out the absolute value of an plus 1 times the reciprocal of an, like this. And now let's figure this out first. For an plus 1, we're plugging n plus 1 into this n and that n, right? So we will have n plus 1 in the parentheses and factorial over this n becomes n plus 1. So let's put this down right here, plus 1. And then raised to this n becomes the n plus 1. So we also have n plus 1 right here. This expression is for an plus 1. And now we multiply by the reciprocal of the original. So we put this down on the top, n to the n, over that on the bottom, n factorial, like this. And now we'll break down the bigger factorial and also the bigger exponent. For this one, n plus 1 factorial, it's going to be the following. We write this down first, whatever we have inside, which is n plus 1. And then the next is going to be, you subtract 1 from here, which is going to be just n. And then the next one is going to be n minus 1, and then n minus 2, and so on, so on, so on, right? For all this right here, it's just pretty much n factorial. And let's put that down. Once again, to break down n plus 1 factorial, it's the same as n plus 1, that's the first factor, and then multiply by n factorial, okay? And for this right here, we keep the base, and then you see we have the n plus 1 for the exponent. So this is the same as saying we have n plus 1 raised to the nth power times n plus 1 to the first power, like this. And now, what can we do to cancel things out? Well, as we can see right here, we have the n factorial and this n factorial, they can cancel each other out. And this is n plus 1, that's also n plus 1, right? So we can also cancel them out. So far this is pretty nice. And now, let's see what we have from here. And you see everything inside is positive, so I can ignore the absolute value. The absolute value doesn't matter anymore, right? On the top, I just have n to the n. On the bottom, I have n plus 1 raised to the nth power, just like this. And both of them have the exponent being n. I can just put it on the outside altogether. In another word, I can look at this as n over n plus 1, and then raised to the nth power, okay? And now, check this out. This is the result after we simplified an plus 1 times 1 over an, right? Equal, equal, equal. We are just doing algebra. We haven't done the limits yet. Okay, as n goes to infinity, look at this. Inside out. Inside, we have n and n, so the inside is going to be approaching to 1. And then this exponent is going to be approaching to infinity. This situation is the 1 to the infinity situation, isn't it? And unfortunately, I cannot draw any conclusion right here. Well, in that case, what can we do though? Remember, we have the n inside and then n as an exponent as well, right? This is a great place to utilize the fact. And let me write this down right here for you guys on the side. So we know the limit as n goes to infinity, 1 plus a over n raised to the bn power. This right here, it's going to give us e to the ab power. And I call this to be the fact. Okay? And you can check out the video in the description. I have shown you guys how to actually work this out. And in the video, I use x, so I can do L'Hopital's rule. But right here, taking a limit, the n and x, same thing anyway, right? Okay, how is this similar to that though? Well, let's see. I want to have 1 plus a over n inside. If you look at the denominator here, we have n plus 1 inside, right here, right? That's the denominator. I actually want to have n in the denominator, so I can have something like this, right? So I can do the following for you guys. Check this out. What I'm going to do is, we are going to flip this fraction inside. Can we do that? Okay, let's put it down first. N plus 1 over n. This is what I want to do. Yes, we can do it, but I have to make sure that this and that are still equal though. If you flip the inside like this, what should you do with the exponent? Well, instead of plus the n, this will become negative n. Can I do it like this? Sure, right? Because remember, when you have the negative exponent, if you have this right here as a fraction, the negative exponent will make this the reciprocal. So that's what we have. And now let's continue to do the algebra from here. And now we see we have n plus 1 over n. I can separate them, and I will take one more step for you guys. This is the same as n over n plus 1 over n. And then raised to the negative n power, right? And of course, n over n is just 1, and then we have plus 1 over n, and then raised to the negative n. How is this compared to the fact now? Well, what's the a value? You see, we have the 1 match, right? We have plus a over n here. This is plus 1 over n, so we know a is going to be 1. So let me just indicate that right here. This is the positive 1, and this is going to be the a value. A is positive 1. And here the exponent is negative n, and we have to have the b times n for the exponent. With that being said, b is negative 1. So let me write it down right here. This, from the fact over there, it is going to be approaching to e to the a times b power, which is 1 times negative 1. And of course, and see, I draw arrow because we did the limit from here to here, right? And 1 times negative 1 is of course just negative 1, and if you would like, e to the negative 1 is the same as 1 over e. And that's pretty much it. So, you see, all this is approaching to 1 over e. We did the limit right here, and this is equal to that, this is equal to that. Okay, this is the limit. It doesn't impress us. You have to remember, we are doing the ratio test. What does this tell us? Well, this is just 1 over e, right? You have to tell me that this 1 over e is less than 1. And this is actually really good because we can draw a conclusion from here. And by the way, e is about 2.7 something, right? 2.71828 and so on. 1 over 2 point something is of course less than 1, so you can check that out. But anyway, this is less than 1, so we can draw a conclusion. And here we go. Let me just write this down right here. Conclusion. Our original series, sum when n goes from 1 to infinity, n factorial over n to the nth power. Since this limit is less than 1, you know this right here converges, and we have to quote this. We use the ratio test. And that's it.